Hi, this is Bharat Brugojo. Today I'm going to explain the solution of the linear models. So here's the code. First of all, we have to uh, load the diabetes set and convert it into a numerical to a categorical. So here we are, first of all, we are doing the mat. We gonna import the matplot library from the library. We gonna use as a plotting function. So and import the numpy values. Here we are using numpy values for the multiplication and addition, the max. So and we're gonna the diabetes data sets. We're gonna import from the sklearn. So here we're gonna load the diabetes of the data sets. So for the labeling, here we are using the data X as a as a labels and the diabetes Y as a features. So if the value is less than mean value, we're gonna set it as -1. So if the value is greater than the mean value, we're gonna set it as +1. So here we are assigning the data sets will load diabetes and return X and Y values as true. So if the X and Y values becomes true, we're gonna return a tuple. So after that, we're gonna print the diabetes of X features dot as a dot shape and the diabetes Y dot shape as a features and the X as a labels. So after printing, we are getting a value of 442 and 10 labels. So here 442 as a diabetes of Y, and here we're getting all the values numerical. So after that execution, we're gonna convert the numerical labels to the category labels. So here we are taking a Y mean, so average mean. We are taking an average. So here we are using a num dot average for the diabetes of Y. Here we got in 152.13 as a average value. The print Y. So we are printing the average of Y. So and next the step is we are going to do a binary. After getting a tuple, we are using a 2D array. So and next here we are using a num value as an array to set. Here if the I value, the average value is greater than mean value, we are getting a +1. So and if the I value is less than the mean value, the average value, we're gonna mention it as -1. And we are printing the diabetes of Y and printing the binaries of Y. Here we are getting a 152, the output as a 152 and the decimals. And after that we are getting these binary values. So and we are doing the data set and split the data into 6 into 2 into 2. So the data will be the data will be divided into 60, 20 and 20 through a training set, validation set and test set. So here the training set will in X train and Y train. So here we are doing so here with the data will be divided into training set, validation set and test set as a 60% as a training set, and remaining the rest is the temp. So here the 60% to a train and the temp to 40%. So the train and the X train, the X temp and Y train, the Y temp is gonna split into the diabetes X and the Y binary. Here we are taking the test size is equal to 0.4, and the as we have talking to the last session, we have taken a random value. There will be a random state. So here we're gonna take as the same the random value will 42, and after that for the 50%. So after splitting into the value, the remaining 40% will be done. The remaining 40, the remaining the here the remaining 40 will divide it into 50 and 50 for the test section and the validation sets, validation here, and end up with the 60% of the train and 20% for the validation and 20% for the test function, test section. So here we are taking X validity, X validation and X test, and Y validation and Y test. And here we are splitting the remaining 40% as a X temp and the Y temp. So here we are taking a 0.5 test size, and the random state is the same. And here we gonna print the X train dot shape for the 60%. Oh, in the here we have got a 442. Yeah, we have got a 442 here. So we are doing 60% for the 442, and we are getting after printing the function, we are getting a 265 here, and the label is 10. So and the remaining 40% will be a validation, and we are doing 50% for that, and the remaining 20% we are getting at 88. So after for this testing test and the training and the and the training set, for the validation set and the test set, we are getting 89 to 65, 89, 88 and 89. So, and after that we're gonna take a linear classifier from the data set and the built-in functions, which are provided from the sklearn. And here we are using a linear model which was taken from the sklearn, and we're gonna import the SGDC classifier, SDG classifier from the library. So the classifier is, we're gonna assign a SDG classifier of the random state to a classifier. So here the classifier dot fit, we're gonna assign X train and Y train, and we're gonna take the two coefficient. We're gonna take one coefficient and intercept. We will be assigning as a theta and theta naught. Here the classification of coefficient we assign as a classification dot coefficient, and the classification dot intercept as an interception. And we're gonna do dimensions here. The first of all, the next step will be a train for the linear classifier. So here already we have assigned the class dot here the classification is equal to SGD classifier of the random state 42, and we're gonna assign classifier of coefficient to the classifier and the classifier intercept to the intercept, and print the here and print the coefficient shape and intercept shape. We are getting 1 and 1 for the coefficient and intercept, and after that we gonna we're gonna implement two utility functions, and we are taking a two matrix multiplication using a num value, and we have here we're gonna compute the we are use sorry here we're gonna predict the values which we here we're gonna predict the values which we are predicting will be wait a minute. So here we are predicting so here we are predicting some values like 1, 10 or something, the values which we are predicting, and that will be converted into binary according to the decision boundary. So after that we gonna train the set, and for the accuracy we gonna return accuracy value if the prediction value and the accuracy value will be same, if we gonna predict that. In the utility function there are for the compute prediction, we're gonna predict the value of X and coefficient and intercept, and the next step is we're gonna so here we're gonna here we're gonna predict the numerical values, and here we taking as x coefficient and intercept in a compute prediction. So we are getting a result as a x. We are taking a num value of matpool x coefficient dot t plus intercept. Here writing a code and predicting a value. If the prediction of the result is greater than 0, we'll getting a 1, and if the result is less than, if the prediction value or the result is less than or equal to 0, we are getting a -1 here. And so here we are using a 1D array to making this. The result will be assigned to the result dot reshape of -1 will be assigned to the result, and we're gonna return the result value. After that, we're gonna predict we're gonna do accuracy of the prediction and the actual value. If we are predicting some value like 1 and 10, we are taking 1 and only 10, that like 1 and 10. So the accuracy value will be 1.1001, something like a decimal number, and the same like as a 10. So, and after that, we're gonna do implement the training set, validation set, and testing set for the prediction set. So for this, we're gonna take the compute prediction as a x train, coefficient, and intercept. We're gonna train as a prediction of train, and the validation and testation, and print the prediction train, prediction validation dot shape, the prediction of test shape. So we are getting a 265, 88, and 89 for the train and training set and validation set and the test set. So after doing that, after completion of the uh, prediction, we're gonna come to accuracy. So the same the same process will be done here. We're gonna implement the accuracy on our predictions, and the same the training set, validation set, and test set. uh, we're gonna test the prediction which are true or false. So here we are taking the accuracy train as uh, the compute accuracy of prediction train and y train. We're gonna assign to train set as the same, the train set, validation set, and the test set. And we're gonna print these three values: the training set, validation set, and test set. And we are getting a 0.7 the decimals, and 0.7 are these three values: the training set, validation set, and the test set. And now we're gonna train the classifier for the prediction set, and the classifier for the score function. And here we are using a building function to use this one and make the classifier as a prediction to be so accuracy. So if the two values are same, our prediction will be true. So here we are taking the building functions. The accuracy, we are taking the classifier dot score value is as x train and y train, and all these values assigned with all these value will be assigned to the training classification accuracy. And here the training set, the validation set, and test set, uh, we're gonna print this value. And we are getting a result of 0.7. This is the training set, this is the training set, and this is the validation set, and this is the test set. So we're gonna check the values. Yes, our prediction is true because here the values and the prediction values are both same. Here's second, the linear regression. So after that, here we are taking a gradient based method, and this is a gradient based method. So first of all, we're gonna import the data sets from the sklearn and make a regression. We're gonna import the regression from the library and import the matplot library as a plotting session. So the code we are taking, so uh, from the whole 442 yeah, here, okay, here we are taking a 442. We got a 442 value. So from that we are taking only so in this regression, the samples of 442, we are taking a only 100 values, and the features is 1. And here the random state will be 42, which was taken in the last assignment, which was pulled by the from the last assignment, and the noise will be 10. Uh, Here we are using a plot function, just subplot. Here, 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 here we are using. చాలా నీట్గా ఉంది. అరే సారీ సారీ సారీ. Here, here we are. Sorry, sorry for the disturbance. So for the mapping, for the plotting, we are taking the size of 10 is to 6, and the dot per inch we are taking an 80. Here, here we are using here we are setting x label as x and the y label as a y. So here we are using a scatter of label and training data set. We are labeling it as a training data. So we're gonna import the datasets from the sklearn and make a regression from the. We're gonna import the regression, and we're gonna so we're gonna import the matplot library as a plotting function. To generate the data set, we are using a regression as the samples are 100, which I have said previously. So here we are using we are taking a figure. So here we are taking a line as a plotting function. We are using a plotting fun. Here we are using a subplots for the plotting. Here we are using a 10 is to 6 for the width and the length, and the dot per inch will be 80. So here we are setting x label as x and the y label as y, and we're gonna do a scatter function. Here we are naming the label function as a training data set, and ax dot legend. Here we are getting a legend at 0x something value. So, and after executing this the plotting, we are getting a training dotted line, the dots here as the cross. So and the next we are taking the next we are taking the gradient descent. Here we are taking the input values x, y, initial slope, initial intercept, the learning rate, the number of iterations, and after that executing all these things, we are getting a slope and intercept. And the first step is initialize slope. We're gonna initialize. First, we're gonna take slope, and after doing execution, we are getting the initial scope, and the initial scope will be again assigned to a slope, and after that written after that printing executing the slope value, we are getting a new slope value. The same will be done for the intercept. Here for the iteration, we are taking 1 and 2, the number of iterations we do, and for the slope and intercept, we are assigning the as the same, the gradient one step, x, y, slope, intercept, and learning rate. So as I've said here, and the next, the gradient descent for one step. Here we are taking the first step, and for the first one, we are taking x, y, slope, intercept, and learning. Here the initial value for the slope gradient is 0, and the intercept gradient will be 0 first, for first. Here the n value will be assigning the length of y. So here the value will be length of y. here we are using a loop function for the range of n. The n will be around 45, which we have taken uh, in the first one. So here using slope gradient, and here we are creating the gradient first step, and we are pulling the values to the gradient descent algorithms. So here the gradient algorithm, the gradient descent algorithm, we are taking the x value, y value, and initial slope, and the initial intercept, learning rate, and the number iteration. So the slope is equal to the initial value of this one, and the intercept value of the intercept is equal to intercept initial intercept, the value of in this one. So after that, we'll be performing a loop from the range of the new iteracy, which we have taken from this. We have pulling, we have pulling, we are pulling the values from the first step to the gradient descent algorithm. So what we are pulling, the initial slope, the initial intercept, and uh, the name numerical iteracy. So after performing the gradient one step, we uh, of x, y, slope and intercept and learning rate, we are returning a slope and intercept. So here the slope and intercept value will be kept in here, the slope gradient and the slope gradient and intercept gradient. Here we are performing a small maths here. So here, okay, here the slope gradient plus will be performed in the first. We will be performing the increment, and then the process will be start. Okay, here we taking the small maths function, minus and minus 1 by n into x of I. I value will be sorry, the I will be the looping function into y of I. So we are taking the return value from the descent algorithm, slope into xi plus intercept, as per the same as intercept gradient, minus 1 by n into y of I. So and slope and intercept. So after doing all this, here a new slope will getting a new slope as a return values, new slope and a new intercept, and we are taking the values here uh, for the parameters. So in this next step, we are taking the learning rate is equal to 0.01, initial slope is equal to 0, initial intercept is equal to 0, and the numerical intercept is equal to 1000. So after that, we are setting initial parameters from this. So for the slope and intercept, the gradient descent will be x, y, initial slope, intercept, learning rate, and numerical. So for here we are doing a plotting. Uh, for plotting, we are taking a subplots, and the figure size of width and length will be 10 and 6. The ratio of 10 and 6 will be a size of the graph, the plotting for plotting, and the the dot per inches will be 80. So here we're taking a scatter of xy and the label, and we're gonna label it as a training data set, and the legs we're gonna set x label as a x and y label as a y. It will, and after that the plotting will be done, and we're gonna sorry, here for the for the plotting, here we are using the color is red and the label as a fitted line. So the cross line is a fitted line here. After executing this, we are getting at the fitted line. The cross one is a fitted line, and this the dotted lines are the training data. So so that's it. Here's the presentation. This is the understanding of my solution. Understanding. Thank you.